Welcome dear students once again into the class of number theory, and in this video we are going to start the new chapter, and the new chapter which we are going to start is binary quadratic forms. So before defining a binary quadratic form, we must know what is a form, what is a quadratic form, and then we will define what is a binary quadratic form. So first of all, let us see what is a form. A form is a homogeneous polynomial in many variables with same degree. So for example, suppose I am writing x cube plus 3x square y plus 4yz square minus 6z w square plus w cube, then it is a form because it is in many variables. It has 4 variables, obviously x, y, z and w, and each term is of equal degree 3. Degree of this term is 3, degree of the second term is 3, the third one is also 3, this is 3 and this is 3. So this form we can write it as fx, y, z, w because it is in the variables x, y, z and w. So this is a form. Then we will move on to what is a quadratic form. It is a form, and then we will look at what is a quadratic form. In the definition of form, I told you that it is a homogeneous polynomial in many variables of same degree. And when we are talking about the quadratic form, the degree, that is, I am saying the same degree of each term, it must be equal to 2. That means a form of degree 2 is called a quadratic form. For example, if I write x square plus xy plus yw plus w square plus wz plus uv plus or minus 2v square, anything that is of degree 2, everywhere you are finding a term with degree 2. It is a homogeneous polynomial in many variables with same degree 2. So it is a quadratic form. In general, a quadratic form with 3 variables, if you want to say, it is of the type ax square plus by square plus cz square plus 2uxy plus 2vyz plus 2wzx. It is the standard, you can say, the quadratic form with 3 variables x, y and z. And here is a term d associated with the quadratic form, and that is the matrix associated, the determinant associated with this quadratic form. And how to obtain this determinant? It is in the diagonals. You just write down the coefficients of x square, y square, z square. So coefficient of x square is a, coefficient of y square is b, coefficient of z square is c. Now this place is reserved. You write here x, y, z. You write here x, y, z. So what you have done, the coefficient of x into x square is being written here. The coefficient of y into y square is being written here. The coefficient of z into z square is being written here. Now let us see rest of the places. Now you are having y into x here and x into y here, but xy and yx, they are the same terms. So what we have to do, we have to write half of the coefficient of xy here and half of the coefficient of xy here. So what is the coefficient of xy here is 2u, and we will write u here and u here. Similarly, this is the coefficient of xz, and this is also the coefficient of xz, and the coefficient of xz is 2w. So what we have to do, we have to write half of the coefficient w here and rest of the half of the coefficient w here. And similarly, this is the place for yz. This is also the place for yz. So what we have to do, write half of the coefficient of yz here and half of the coefficient of yz here. So the coefficient of yz is 2v. You write half v here and v here. So when you will solve this expression, you will get, I think, ABC plus 2UVW minus AAU square minus BV square minus CW square, something like that. And that will be the determinant of this quadratic form. Then we move on to the next thing. The main thing, that is the name of the chapter, is binary quadratic form. And now I am going to define binary quadratic form. Earlier we were defining quadratic form, and now I am defining binary quadratic form. So what it is a quadratic form. It is a quadratic form. So when I am talking about quadratic form, obviously degree is 2. So it is a quadratic form with two variables. Quadratic form with two variables, and it is called a binary quadratic form. For example, the standard form of the binary quadratic form is ax square plus 2hxy plus by square. This is the standard form of binary quadratic form. So we write it as fxy. So fxy is equal to ax square plus 2hxy plus by square is the binary quadratic form, and degree is obviously 2 and the number of variables is clearly 2 because it is binary quadratic form. In general, the binary quadratic form what we will use in this chapter will be ax square plus bxy plus cy square. And now look at its discriminant. The discriminant d is, now it is determinant of order 2 because you are having only two variables. So what you have to do, you write x, y here, write x, y here. The coefficient of x into x, that means x square, is a. So you put it here. The coefficient of y into y, you have to write here y square. So y square's coefficient is c. You put c here. Similarly, this is the place for the coefficient of xy. This is also the place of the coefficient for xy. So what you have to do, half of the coefficient of xy will be written here and half of the coefficient of y square will, xy will be written here. The coefficient of xy is b. You write down half b here and half b here. And now just simplify this determinant. You know that how to simplify it. It is ac minus 1 by 4 b square, or you can say by taking 1 by 4 common, it is 4ac minus b square. So this is the discriminant of this binary quadratic form, which is written as ax square plus bxy plus cy square. So this is the definition of the binary quadratic form. Now there are many types of binary quadratic forms. Some are positive definite forms, some are negative definite forms, some are zero forms, some are indefinite forms. So let us see what these types of binary quadratic forms are. So first of all, I am going to define positive definite form. So positive definite form. It is a type of binary quadratic form now. So a binary quadratic form, I am writing in short BQF for binary quadratic form. A binary quadratic form fxy is said to be positive definite form. Positive definite form if fxy is greater than 0 for all xy belonging to z, the condition is that xy both should not be 0. Xy both should not be 0. So if for every x and y, every ordered pair xy, where both x and y are not 0, if this fxy is always greater than 0, then this fxy will be called positive definite form. And similarly, you can define negative definite form. So what is negative definite form? It is also a binary quadratic form fxy. It is said to be negative definite now because we are defining now negative definite form. So it is said to be negative definite form if fxy is now less than 0 for all xy belonging to the set of integers with xy both not 0. One can be 0, but both x and y cannot be 0. And the third important binary quadratic form is zero definite form. Zero definite form. So a binary quadratic form fxy is said to be zero definite form. Zero definite form if there exists x, y belonging to z, again x, y both not 0, such that f of xy is equal to 0. So it is the definition of zero definite form. I am giving you the examples also. For example, if you take fxy is equal to 2x square plus 3y square, then it is positive definite. Because whatever the values of x and y you substitute here, the value of fxy will definitely be greater than 0. So this is an example of positive definite form. And if I replace both the signs, positive signs by negative, so fxy is equal to minus 2x square minus 3y square. So this is an example of negative definite form, because now whatever the values of x and y you substitute here, the value of fxy will be negative. Another example, look at this example, x square minus y square. This is zero definite form, because here you have x is equal to 1, y is equal to 1, such that f of 1, 1 is equal to 0. So there exists x, y both not 0, such that fxy is equal to 0. So it is an example of zero definite form. And then there is another type, that is indefinite quadratic form. I am writing here indefinite form. A binary quadratic form fxy is said to be indefinite form if it can assume any value positive, negative or even 0. So the same example which I have given the previous one, fxy is equal to x square minus y square, here if x is greater than y, the value will be positive. If y is greater than x, the value will be negative. And if x is equal to y, the value will be 0. So this binary quadratic form is an example of indefinite form. So here I have defined several kinds of definite forms with examples. And now there is one more definition, that is reduced form. What is a reduced form? A binary quadratic form is said to be reduced form if the discriminant d is not a perfect square, and minus of mod a is less than b is less than or equal to mod of a is less than mod of c. So if these two conditions are satisfied, that means the discriminant is not a perfect square, and minus of mod a is less than b is less than mod of a is less than mod c, or you can also write this inequality as mod of b is less than mod of a is less than mod of c. If you can write it in this form also. So here you can say that 0 is greater than or equal to this. So if these two conditions are satisfied, then the binary quadratic form is said to be the reduced binary quadratic form, or you can say it is the reduced form of the given binary quadratic form. So these are some of the definitions, some of the kinds, some of the types of binary quadratic forms. And now I am going to take some very easy, you can say trivial examples or results related to the binary quadratic form. So this is a theorem, you can say. This is a theorem which I am going to prove now. Let fxy is equal to ax square plus bxy plus cy square be a binary quadratic form with integral coefficients and discriminant d if d is not equal to 0 and d is not a perfect square, d is not a perfect square, then a is not equal to 0, c is not equal to 0, and only solution of fxy form to be equal to 0 is x is equal to 0, y is equal to 0. This is the only solution. There is no other solution possible if you are having these conditions. So let us move on to the proof of this theorem. So see that what you are given and what we are to prove. We are given the binary quadratic form fxy is equal to ax square plus bxy plus cy square. This binary quadratic form is given to us. Also, it is given that the coefficients are integers. That means a, b, c are all integers. Another thing is given that d is not 0 and d is not a perfect square. And now we have to prove that a and c are not 0. If a is 0, suppose your a is 0, then what is your d? D is 1 upon 4 b square minus 4ac. Now substitute the value of a here, you will get half of b whole square. So it will be a perfect square. So better if we consider the discriminant as b square minus 4ac instead of 1 by 4 b square minus 4ac. So it will become equal to b square is a perfect square, which is not possible because we are given that the discriminant is not a perfect square. So this case is not possible. So a cannot be 0. Similarly, if c is 0, the same result will be there. D will again be equal to b square. That means a perfect square, which is not possible. So that means a cannot be equal to 0 and d also cannot be equal to 0. So one thing we have proved that a is not 0 and c is not 0. Then we also want to prove that the only solution is x is equal to 0, y is equal to 0. One thing is clear that f of 0, 0 is equal to a into 0 square plus b into 0 plus c into 0 square is going out to be equal to 0. So f 0, 0 is equal to 0. That means fx y is equal to 0 has this solution x is equal to 0, y is equal to 0. What we have to prove that there is no other solution. Suppose if possible there is some other solution. So let x1 y1 be a solution. So that means f x1 y1 will be equal to 0 for all. So what you will get, a x1 square plus b x1 y1 plus c y1 square is equal to 0. Now we are given that a and c both are not 0 and this is true. This is the solution. So if you take your x1 is equal to 0, what you will get? C y1 square equal to 0. Since c is not 0, so that means y1 will be equal to 0. So if x is 0, y is 0. If y is 0, x is 0. So both x and y cannot be equal to 0. So there is the only possible solution of this binary quadratic form is 0, 0. There are many theorems we have to prove in this chapter of binary quadratic form, but In this video, I'm going to this video here. In the next video, we will have more and more theorems, more and more results based on binary quadratic forms. Till then, thank you. Thank you once again.